Welcome, GeoTrig. This is section 4-2, Triangle Congruence by Side-Side-Side and Side-Angle-Side. The essential question is, why don't you need to know all the angles and all sides of the triangles to prove that they are congruent? Let's begin. So last time we talked about proving congruent shapes. And one way we did this for triangles is we needed all three angles and all three sides just to prove they're congruent. But now I'm going to tell you something different. So what you need to know now is you don't need to know all the sides and all the angles. There's actually a few combos that'll work, and if you know those combos, then you can say they're congruent. The four combos are right here, and we'll talk about it this week. So the ones we're talking about in this section are the first two, side-side-side and side-angle-side. So the first one, side-side-side postulate. So what this says is if you have three sides of a triangle and they're congruent, then the two triangles have to be congruent. So in this picture, AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF. Since all three sides are congruent, we can say the triangles are congruent to each other. And just a reminder, what's a postulate? Postulates are something that we accept as fact. So when I say the side-side-side postulate is true and that makes it congruent, this is something you have to know and you accept it because this is true. And why is that true? You might want to just maybe explore with some things. I mean, it's just if you lock in the sides of the triangles, there's no room to change the angles in those triangles at all. It has to be locked into one shape. If those sides are locked in, the shape's locked in. So let's use that statement in a proof. So we're given on this shape here, LM is congruent to NP and LP is congruent to NM. Those are marked in the shape. We're going to prove that the triangles are congruent. LMN is congruent to NPL. So statement number one is the givens. Our LM is congruent to NP and LP is congruent to NM. Why do we know this? Because it's given. It's always our first. Now step number two. Well, what else do we know? Well, these two triangles, we can see that they actually share a side right here. We can call this side 3. So we can create a new side and say side NL is congruent to side LN. Why? Because they are the same side. The same side. Or the triangles share sides. So now that we know all this side is congruent with that side's congruent with this, and this side's congruent, well, for both triangles, we can say that triangle LMN has to be congruent with triangle NPL. What's my reason for this? It's easy. Side, side, side. So SSS, and then we say triangles are congruent. Something like that. So by the side-side-side postulate. Alright, let's do the other one. Side-angle-side, SAS postulate. So this says if you have two sides and the angle that's in between those two sides, then you have congruent triangles. So we have sides AB and AC are congruent with DE and DF. If you have that angle in between and those two sides, we can say the whole triangle is congruent. Now, one way to think about this is if you're measuring a box. Like sometimes you want to see if something fits through a door. And this is a really good example. So you put your hands out there, just like this picture, and you measure it, and then you twist your body to see if it'll fit through the door. That's basically what you're doing, the side angle side postulate. Your hands are the angles, and the lengths of your hands are the side, and then it's an angle between your two hands, and you're not changing that angle. And you know that another way to say this is if you know the two sides, there's only two possible angles here. These sides can't grow. This angle and this angle are locked in. Alright, let's actually do an example of this. So what are the information you need to prove triangle DEF is congruent with FGD? So we know some information here, and we want to prove it by side angle side. Well, I know these two sides, EF and DG, are congruent. I also know, since this matching one in the middle, these two triangles share that, DEF and FGD, they share that side. But the last thing I need to know by side angle side is some angle. So you've got to have that angle part. So which angle do we need to know, though? Don't just say we need some angle. We know specifically which one. And since for this triangle DF, this triangle on the bottom here, the angle that's between these 2 points is right here. So this angle. And the other matching or corresponding angle would be this one up here. So what information do we need to know? We need to know that angle, let's call this GDF, is congruent with angle. And matching this up, it'll be EFD. So we need to know that these are congruent. That's the missing information to prove by side angle side. Alright, moving on. Alright, try these examples. Pause the video. Alright, let's begin. Can you prove congruent by side angle side, or is there not enough information to prove either one? Because you have to be careful with the order. So for these first two triangles, I have matching sides, and a side, the 2 and the 1, and then there's an angle in between. Well, side angle side, side angle side. So I can prove this by side angle side. So that matches up. Let's try the one over here. We got side 1 angle and side 2, and we got, but see, this is not, we can't prove that because we got this side matches and this side matches, but the angle's not in the right spot. It's got to match. If this was side 1 angle and then side 2, that would match. But this 2 is in a different place, so that doesn't work. So we say not enough. So you got to watch the order too. It's got to be corresponding. The order matters. It just can't be two sides and some angle. It has to be matching. So let's take the next one here. I know side 1, side 2, side 3, side 1, side 2, side 3. So this is good by side. And this last one, side 1, side 2, side 3, side 1, side 2, side 3. That's side as well. All right, pause the video. All right, what other information do you need to prove this triangle? By side angle side. So I got these angles. And what side? Well, I got this side because these two triangles share this one side. Now I need another side. Which side do I need though? Do I need this side, the edge of the box, or do I need the top and bottom? But following that pattern of side angle side, I know this angle has to be in the middle of the two lines. So it's got to be the segment up here and the segment down here. So what I need, specifically, I need LE, segment LE is congruent to segment, be consistent, BN. So that's what I need. I don't need LN and EB. I need these two segments are congruent. That's it.